Hello everyone, today you will learn about the 6 different types of numbers which are classified into 2 main groups, rational and irrational numbers. So let's look at a few numbers. So we have the number pi, the number 2, and the number -16. So pi is a number that goes on forever. So like 3.1415. It goes on forever, unlike the number 2 and the number -16. It is also a positive number. The number 2 is positive. The number -16 is negative, unlike pi or 2. As you can tell, there are certain similarities and differences between these numbers. Let's learn how to classify them by starting with the first type of number category, natural numbers. So natural numbers do not have decimals. Do not have decimals. So it cannot be a number like pi, it cannot be a number like 2.5. These numbers are positive, so numbers above 0, and these numbers start at 1. So this means that the number 1 is included as a natural number, but the number 0 is not a natural number. Let's look at a few examples of what natural numbers are. So we have the number 1, we have the number 96, we have the number 298, the number 7. So you can tell all these numbers do not have decimals. They are positive numbers, and they all are 1 or above. So our second type of numbers are called whole numbers. Whole numbers are similar to natural numbers. They do not have decimals. They are also positive. And this time, the number 0 is included, so start at 0. So 0 is a whole number. So examples would be 0, 1, 92, or 92, 87, 2,341. Our third type is integers. So integers do not have decimals. Just like the other two. And these numbers are positive, negative, and 0. So a couple examples include -16, -5, 0, 5, 16, -11, and so on. Moving on to our fourth type, which are rational numbers. So rational numbers are any number that can be written as a fraction. Any number that can be written as a fraction. Great. So a number like 0.5, a number like 1.75, a number like 87. So just recall that the number 87 does not have any decimal places but can be written as 87 over 1. The number 1.75 can be written as 1 over 3/4. It can be written as, this 0.5 can be written as 1 over 2. So we're going to come back to the second rule, but let's look at a few examples. So we've looked at a few examples over here. So 0.5, 1.75, and 87, these are all rational numbers. Going on to our fifth type, which are irrational numbers. So irrational numbers cannot be written as fractions. They're the opposite of rational numbers. Cannot be written as fractions. Great. So the next rule is that these numbers go on forever. And so do rational numbers. So rational, going on to our second rule for rational numbers, these numbers go on forever as well. So how do you tell which one it is? Well, the difference between rational and irrational numbers is that rational numbers go on forever with a pattern. So it would be in something like 3.141414. So you could tell the pattern 14 repeats itself. Or it could be something like 7.29555. So you can obviously tell the number 5 repeats itself. General rule, include the pattern at least 3 times, and then include the 3 dots to indicate this. And irrational numbers go on forever without a pattern. Without pattern. So, for example, pi or root 5. So root 5 has a pattern that does not repeat itself. So 2.6, 3606. There's no obvious pattern here. And then pi obviously does not have a pattern. 3.14159. No pattern there. So going on to our last type of numbers, which are real numbers. So these numbers include all types of numbers that we just went through. So all the 5 types: natural, whole, integers, rational, and irrational numbers. And these numbers fit on the number line. So all these numbers that we just talked about, all of them fit on the number line. Great, so let's look at an example. So pi, 3, 1 over 2, 3.759, and 4.61333. So these are all numbers that fit on the number line, and they're all types of numbers. So let's go back up to where we had our 3 numbers. So let's list the 6 types out right here. So one, we have natural numbers.
We have whole numbers. We have integers, rational, irrational, and real numbers. Great. So let's look at these 3 numbers over here.
So the number pi is a real number. It is irrational because it goes on forever without a pattern. It is not rational because it goes on forever without a pattern. It is not an integer, whole number, or natural number because it includes decimal places. So going on to our second number, which is the number 2. So 2 is a real number. It is rational because it can be written as 2 over 1. It is an integer because no decimal places, and it is a positive number. It is a whole number, and it is a natural number. Going on to our third type, third number, negative 16. It is a real number. It is rational. Can be written as negative 16 over 1. It is an integer because it is a negative number. It is not a whole or natural number because it is negative. So there are a couple ticks that overlap each other. So for example, 16 is a real number. Number is also a rational and integer. So we can classify this into a table or diagram like this. So let me just move this up. So we know that. Let's look at pi first. So pi is a real number. It is rational. So we have pi over here. So pi fits the chart for irrational and real number. Great. So moving on to number 2. It is a real number. It is a rational number. It is an integer. It's a whole number. And it is natural. So 2 goes over here. Negative 16 is a real number. It is rational. It is an integer. It is not a whole number or a natural number. So 16 goes over here. So this is the most specific kind of characterization. So when they ask you what type of number is negative 16, it's an integer. The number 2 is a natural number. And the number pi is a irrational. It is an irrational number.